Hi everyone, Queeveen here from the comfort of my kitchen. In today's video, we are going to be looking into the future. And of course, on this channel, we almost always look into the future. It is a pretty rare event that I will look far into the past. We almost always look into the future. We're looking into the future here as we were in the last video because I do want to prepare people for stuff that is coming up. I have in the past, if you go back on my videos, I believe it was last year, looked much further into the future than I normally do, all the way up to 2061 for the return of Halley's Comet. So if you would like to prepare yourself for 2061 and the return of Halley's Comet, that is something you can do by viewing the videos on my channel. Of course, there's no rush to do that now, given that we're going to be waiting until 2061, but it doesn't hurt me if you go back and review the videos on my channel. You know, I'd certainly be thankful. However, we're going to look even further ahead a little bit later in this video, but to begin with, we're going to take a look at Mars. Now, I'm going to try and do this correctly. We're going to come up to midnight, and I know the opposition of Mars was actually a little bit ago. You can see that we're only at 94.3% full, and we're here at 9 o'clock, and Mars is directly above the south. So these are all signs. The fact that it's not 100% full or close to 100% full, the fact that we're not seeing it directly above the south at midnight, all of these are signs that Mars isn't at opposition. Pushing back here to earlier in January, and we're seeing it there. That's still a little bit late for it to be coming up to the middle. If it was at opposition, we're seeing it there, yeah, pretty close to 1 o'clock, a little bit after 12. Of course, we have to adjust for Greenwich Mean Time and the size of the time zones when we're at the edge, not almost at the edge, closer to the edge than we are to the center. That might not be true. We're definitely off the center towards one edge. The exact relative distances is something that I haven't worked out. Not that it matters. All that matters is that we're seeing Mars here nice and bright because it's at its brightest, because it's at opposition. We're seeing it there at -1.5, basically, reduced to -1.27. We're looking for bigger negative numbers, which of course means lower on the number scale. A higher on the number scale into positive numbers brings you to a fainter object. And we can see here, comparing it to Jupiter, there's Jupiter at -2.6 reduced to -2.44. So we can see here that Mars at opposition for this year is still only half as bright, roughly half as bright as Jupiter. And Jupiter is not even at opposition. You know, Jupiter's not super far off opposition, but not at opposition nonetheless. If we go through time here, of course the moon will get in the way and the ground will get in the way, and I don't want any of those things to get in the way. We're seeing it here at -1.43 without the extinction because I've gotten rid of the atmosphere. We're going to move through time, staying focused on Mars. We can see it doing its little weird loopy thing there, and we can see it's already into positive numbers. It's already just that much fainter, and we can see how faint it is, kind of varying a little bit. We're seeing it getting down there to about 1.3, 1.4. So that is definitely, you know, on par with a lot of stars. For example, just here, we can see there's some relative sizes, which are indicators of brightness. There's Mars at 1.7, really not that bright. That makes it fainter than Arcturus, magnitude 0.15, fainter than Spica, nearly magnitude 1, 0.95. There's Mercury, magnitude 0.4, and there is Venus, -4, the Moon, -7, all much brighter than Mars there at positive 1.6, which of course is fainter when we're in those positive numbers. We can see it's because it's very far from us there. We're still seeing the side of Mars that's facing the sun. We always see the side of Mars that's facing the sun, but it's further from us on the far side of the sun, and coming around here to opposition last year, -1.97, practically -2. Brighter. So Mars's opposition was brighter back in 2022. We've gone back a couple of years here. Of course, the exact time it takes for Mars to come back to the same position in the sky isn't the exact same as simply traveling forward a year like it is for the stars, because Mars has its own orbit around the sun. But we can see there it's practically -1.9, not the -1.6-ish, 1.6 before the atmosphere. That we were seeing, or -1.43, that's what it was when we were seeing it at opposition this year in January. These things Vary. Exactly how bright Mars is varies depending on exactly how close it is to us during opposition, because of the two elliptical orbits going on there. When we are at our closest to Mars, if Mars is at opposition while we are at perihelion, if Mars is at opposition while we are at antihelion, the same for Mars. You know, we could both be at perihelion, one could be at antihelion, one could be at perihelion. We really want the Earth to be at antihelion. We want the Earth to be the furthest away from the sun that it's going to get, and Mars to be the closest to the sun, and with us in between, the closest to us. That's really what we want. So we're going to go through some time here. It does look like Mars is, yeah, roughly in the right position in the sky. It doesn't have to be exact. We just have to make sure that we stay locked onto Mars here as we jump through the years. So we're not going to see it exactly at opposition every single time here, because of the way its year varies. We'd really have to be going for Martian years here. But I do have it on some authority, and that is to say, someone in my comment section told me that 2033's opposition is particularly bright. Here, we're not seeing Mars at opposition. So we're going to go through, not just a few minutes and hours, we're going to go through days here to try and get Mars up to opposition. We want to see that brightness coming down, because the lower the magnitude, the brighter the object. We're getting up into the 99.9% full. Now, we're still not seeing it at 100% full, but that's probably down to the level, and we're seeing it there at negative 2.57. Significantly brighter, almost as bright as Jupiter. There's Jupiter at minus 2.56, and there's Mars at minus 2.57, which is a bigger number. That's further down the number scale. So it looks like, here we are, 2033, Mars is going to be brighter than Jupiter. That is not the brightest that has been reported to me. Now, let's see if this works out, because I am going off something that I have been told by a commenter, so of course I have to check. It's always good to fact check things. Never just believe anything blindly if you can avoid it. So we're coming up to 99.9. Oh, it looks like we're only getting to 99.8. Again, this could be down to the tilts involved, but there we are. Mars directly above the south at 1 o'clock in the morning. So again, we do need to adjust for things like the shape of the time zones, but there we are, minus 2.8. That's just incredible. That's incredibly, incredibly bright. So we're seeing Mars there at its brightest in 2097. So I hope some of you can look forward to that. I am generally a rather hopeful and optimistic person, but 2097, I would be over 100 years old by then. And who knows, maybe I will make it to over 100 years old, but statistically it is unlikely, and it is important to acknowledge those kinds of realisms. I may realistically make it to 2061 to see the return of Halley's Comet. However, 2097... I'm healthy, but I don't think I'm that healthy. We're going to come all the way back now. It seems like very far back, all the way back to 2025. There were a couple of other things that I wanted to show here, but I don't think I'll be able to show them in the space of just 2 minutes. So instead, what we're going to do is we're going to bring back everything. We're going to head out to the countryside, and we are going to move forward to just one more thing. And I want to make sure that this thing is visible from the Earth, but we're looking for planets. And just like we're still months into the future here for 2025, coming all the way back now to late February, because of course it is late February when we get all of the planets in the sky. Now I'm there on the 28th. I don't think it's actually the 28th. I don't think it's the very last day of February. I don't believe that the very last day of February will give us the best view possible. Yeah, the atmosphere is still on. We're just in a very, very pristine, dark location. Yeah, so Mercury is a little bit lower there than Saturn on the 23rd. If we bring it up just a tiny bit, that's about as close as we're going to see them together from here in Ireland. I think we'll see Mercury a little bit closer to Saturn on the 24th than we will on the 25th. It seems just a little bit higher than it, even though the actual, they look level here, which makes them seem a little bit closer together. We're going to take in these planets for a second. We've got Saturn, we've got Mercury, we've got Neptune, we've got Venus, we've got Uranus, we've got Jupiter, we've got Mars. They're all visible there. They're not too spread out across the sky even, just from the southeast down to the west. It's almost like, we're looking at a section of the ecliptic curve here, you know, only a quarter of the whole circle, give or take, probably a little bit more. But again, we are going to travel forwards. We're going to travel forwards to 2040. We're going to go forward to September. It's October. There's September. And we're going to go forward to, I believe, you know what? We're in September. We're in the right year. I won't have to worry too much about it. Let's just take a look at this here month. Now, we should have a lot of planets in the sky here. I'm not seeing them, but they may just be very, very close together. Let's go through a couple of days here and see if we can get things right. Okay, so we're not seeing all the planets in the morning, that's clear. And it looks like we're not seeing all the planets in the evening either. So this implies to me that the planets are all going to be up during the day. So let's get rid of that atmosphere. And there they are. Wow. Jupiter, Mercury, Saturn, Venus, Mars, all super, super close together. And it looks like from here in Ireland, they're too close together. Because we're seeing there, yeah, the sun is barely dipping under the horizon by the time Jupiter, Mercury, and Saturn. And Mercury, they're all there. Well, not all. I don't think. Well, Neptune shouldn't be too far away. We're only a few years into the future. There they are. So we can see those planets, all of the planets that are visible to the naked eye, clustered way, way closer together than they are for the current parade of planets. And if you're a little bit closer to the equator, you might actually be able to see it. But we will revisit that at least in 2040, possibly before. And if you want to catch that video, make sure to subscribe to my YouTube channel and possibly my website so you'll be reminded when I'm posting something new. If you enjoyed this video, please do like it. As I mentioned, you can take a look on my website if you'd like to read some of this information. It's all typed out there. Make sure to like this video if you enjoyed it, subscribe to my YouTube channel, check out my website, queevinscontent.ie, and hopefully I'll see you back here next time.